All right, let's do it. So this talk is called How to Get a Service Mesh into Production Without Getting Fired. So here's the situation. Okay, you're standing at the edge of the precipice, and off in the distance you see service mesh land, where everything is wonderful. As we know, having been at KubeCon for this long, we know that that's where all of our problems are solved. But before you can get there, you have to cross over Failure Valley, and you're kind of peering over, and down there are the bones of the person who tried to do this before. So how do we get from here to there? Okay, I'm going to tell you a little bit about me. My name is William Morgan. I used to write code in the good old days. Now I mainly write email. I work at a company called Buoyant. We're based in San Francisco. We have two open source service mesh projects. One is called Linkerd, which is a CNCF project. One is called Conduit, which is a lot newer. I'm actually not going to talk too much about the details of what these things are. There's a whole bunch of other talks about them today, and I'll have a list at the very end. But suffice it to say that we have been putting service meshes into production for almost 2 years at a host of companies around the world. I've put some of the big fancy logos up there, including our friends from Monzo, but also a lot of small startups. So we've kind of seen, you know, the range of things. Okay, and this talk is going to be about two things. This is actually the first talk I've done for a long time that doesn't have a demo at the end. It's just going to be words. So the first thing is, it's going to be about manipulating human beings. Okay, and then the other part is it's going to be about good software engineering practices. A little bit of this is going to be service mesh specific, but in reality, getting a service mesh into production is not really that different from getting any other kind of complicated tech into production. It's maybe just a little bit more so, because where the service mesh sits is in a very mission critical part of the stack. So it's a little scarier. Okay, and at the end of this talk, you will be prepared to do this, or you'll at least know why this is not a good idea. So, question number one, are you really going to get fired, right? If you really work at a company where you try and get a service mesh into prod and it doesn't go well, and you're actually going to get fired, then just come talk to me afterwards, because there's a better company that I can talk to you about. Okay, that should not be a realistic failure scenario. So what are the realistic failure scenarios? Well, here's the 4 classes. So over the past 2 years, I'm going to try and distill all of that wisdom into a set of easy to follow instruction guides. All right, so the 4 ways that we actually see people fail with the service mesh is, number 1, you can't convince your colleagues that it's a good idea. So in most companies, there are other people who you have to convince, right? It's not just you. Sometimes it is, and that's a very nice company, but most of the time, there's other people, and that's why a big part of this talk is about how to convince other human beings. Okay, the next way that getting the service mesh into prod fails is you manage to convince your colleagues, but then when you actually try and roll it out to production, something breaks and you have to stop. Okay, failure scenario 3 is you get it into prod, and things start going wrong, and it's not your fault, but you get blamed anyways. I'm going to talk about how this happens and how it's unavoidable, but how you can survive it. And then finally, failure scenario number 4, things go wrong and it is your fault. So we'll go through those one at a time. All right, failure scenario 1. You can't convince your peers that putting the service mesh into production is a good idea. So first, I think we need to ask ourselves, is it actually a good idea? Why do you want to do this, right? What problem are you trying to solve? And it's shocking to me how often this comes up. So I'm going to play a little game. This is an audience participation game. This is the only time that I'm going to, ask you to get involved until the questions at the end. It's the only time when you don't have to just listen to me talk and talk. All right, this is a game called Good Problem, Bad Problem. So I'm going to state a problem, and then you have to shout out, is this a good problem or a bad problem? And a good problem means this is something that we can use a service mesh to address, and that we should use a service mesh to address. And bad problem means, no, we shouldn't. Service mesh is not the solution for this problem. So let's start. We'll start with something easy. Okay, here's a problem. The problem is we need a service mesh. Shout it out. Is this a good problem or a bad problem? Survey says, bad problem. That's right. That's not a problem, right? That's a statement of fact. We don't have a rocket ship, so therefore we need to buy a rocket ship. No, right? The problem should be something like, I want to go to the moon, and therefore I need to buy a rocket ship. Okay, next one. Our services are written in 6 different languages, and we don't have consistent telemetry libraries across them. Good problem, bad problem? All right, you guys are on the ball. That's a good problem. This is a concrete problem. It's something the service mesh can address. There's other ways of solving this, right? It doesn't have to be the service mesh, but this is an actual problem that can be addressed. Okay, here's a good one. We want to be cloud native. Cloud native is cool. We're at a whole conference about this thing. Good problem, bad problem? I heard some goods and some bads. Survey says bad problem. Right? That's not a reason to install a service mesh. All right, I think we're almost near the end of this. We have 70 service teams. Getting them all to add TLS to their services would be not an impossible technical task, but an impossible organizational task. Good problem, bad problem? Survey says good problem. Okay, so you guys are catching on. Okay, last one. I added this at the very end. All right, Google made Kubernetes, and we love Kubernetes. Google makes a service mesh, and therefore I need a service mesh. This should be easy. Good problem, bad problem. Let's shout it out. Yeah, bad problem. That's right. There might be great reasons to do it, but these are not the great reasons. All right, so believe it or not, even though my goal in life is to convince you to install a service mesh, because at the end of that journey, somehow I get paid, a service mesh is not actually always the answer. You have to make sure you're solving the right problem. Okay, so here's my guide. I've put this in a very easy set of 4 steps that anyone can follow to convince human beings, all right? How to convince your colleagues and your peers, all right? Number 1, you got to identify who is going to be affected by this, all right? These are called the stakeholders if you're in the enterprise. You got to determine what the service mesh improves for them, right? These are the incentives, these are the carrots that you can dangle to make them excited about this. You've got to understand what they're worried about, right? Okay, because they are going to be worried about something, and then you have to mitigate those concerns, extol the incentives, and communicate, right? Well, it's easier said than done, but this is called getting stakeholder buy-in. And I'm going to tell you something horrible, something that's just going to make the rest of your life feel like it's just a sham, which is that Morgan's fourth law, this is my 4th law, any sufficiently advanced engineering work is indistinguishable from sales. If you get really, really good at engineering, you will become a salesperson. All right, so here's some examples. I'll go back so you can take a picture of that. Morgan's 4th law. Yeah, that's a good one. All right, so here's some examples. I'm not going to go through these, but I just wanted to kind of give you, a sense of who are the possible stakeholders that I might have to talk to, what kinds of things would they be interested in, what concerns might they have. So platform engineers, right, these are the folks typically who are introducing Kubernetes, introducing the service mesh, building the internal paths, however you want to call it, right? And they care about a set of things and they are concerned about another set of things. Another stakeholder in this process are the developers or the service owners who are going to be writing the code and mostly don't want this thing to get in their way, right? And then you have the security team who's paid to make things secure and have a set of interests and desires. And then you have senior management who cares about kind of higher level things like how fast are we moving and is this going to cause more outages. I'm going to post the link to these slides and they'll be on the CNCF like slide thing so you can go through this in detail. This is not comprehensive, it's just kind of a random sample of possible incentives and concerns. All right, so let me talk about a case study. So this is a real life thing, all right? So 4,000 person educational company. And the way that this company works is that they have these extremely long running feature freezes, right? They deliver a product, it's for a school system or something like that, right? And the customers don't want anything to change for 9 months, right? They're like trying to teach a class. They don't want features to change. They don't want to have to learn anything new. They don't want the little pop-ups that say, hey, let me tell you about these new features. Take a tour. Like, I'm just trying to teach my class, all right? So they basically have these 9-month feature freezes, okay? But at the same time, this is all built as microservices, and you got lots of different customers, and you're trying to make progress on and go through, advance the feature roadmap. So life is difficult, right? And the incentive that our service mesh champion said, this was with Linkerd, we can run parallel service versions concurrently. It's going to be really easy because it's got this fancy routing thing, and that way you can continue iterating, and we've decoupled the deploy process from, the fact that we have this, or the development process from the fact that we have these long-running deploys. The concerns were around reliability, like what's this thing, is it reliable, how do we have to change our workflows? And he addressed the concerns via testing and education, right? And it's great. Now they are happy service mesh users. They've been in production for over a year. So that's a happy one. I've got some sad ones coming up. Okay, so that was failure scenario 1, right? You have to convince your peers. All right, so now scenario 2. You convinced your peers, following my handy 4-step guide, but the rollout to production fails. So we've seen this, and often when we see this, it's because you're trying to take on too much, right? You're trying to boil the ocean. You haven't addressed the risks that are going to be a part of this, or sometimes you haven't communicated the value, or you've taken too long to communicate the value. If it takes 12 months to do this, well, by the time month 4 rolls around, people might start wondering what's going on. Okay, so quick case study here. Multi-billion-dollar financial company. Deploy the service mesh, Linkerd. Very complex rollout. Multiple configurations, multiple environments, Kubernetes, non-Kubernetes, blue-green deploys, Nginx was in there, hardware load balancers, just a very sophisticated stack. And shortly thereafter, started to experience problems. And not just like, we gotta just gotta change this config thing, but hard to reproduce issues that they didn't see in staging, right? And it was very difficult to understand what was going on. You could put mitigations in place, but the mitigations were really awful, right? And almost got to the point where they ripped Linkerd out, okay? Okay, and apparently I have a typo in here. Luckily, we fixed things before this. Okay. Also, emojis did not translate, so those little squares are supposed to be sad faces, and then the cats are supposed to be kind of screaming cats. All right, so the root cause was Linkerd had some bugs. Yes, this occasionally happens, believe it or not. Hardware load balancer also was misconfigured and had some weird behavior / bugs. But those were actually the minor issues. The real problem was all the compounding factors. The fact that the environment was so complicated that there wasn't enough communication that was happening internally and externally, and also it was just difficult to understand Linkerd's internal state. Right? So what lessons did we learn from this? Number 1, start small, right? 1 configuration, 1 environment. Of course, you're testing this before you put it into prod, but the reality is, once it's in prod, it's different. You never catch everything, all right? So start small. There are product features that can help with this. So one of the things we've really tried to do with Conduit is make it very easy to incrementally apply the service mesh to 1 service at a time. Okay, so start small, encourage communication. Sometimes it actually takes work to make different teams talk to each other, believe it or not. Network team doesn't want to talk to the OS team, doesn't want to talk to the platform engineers. So sometimes you just have to mash heads together. And then good diagnostics. So this was a real lesson for us with Linkerd. You've got to be able to clearly reason about what the service mesh is doing when things go wrong. Okay, so this is another thing where product features can help. So diagnostics. I'd say if there's one thing that we learned as service mesh purveyors, as vendors, service mesh vendors, the one thing that we learned was that diagnostics are critical. You have to have this, because all the production bugs you're going to see are these hard to reproduce things that, we can't take your environment and run it in our own little, in our environment and figure out the issue. We have to rely on you to do this. So you need diagnostics. Here's some screenshots of this is the Linkerd admin dashboard, and here's some of the state dumping features, and Conduit has a dashboard that's just saying, hey, here are the different parts of the service mesh, and they're all working or not working. I've got a couple examples. I won't spend too much time on this, but we have headers that kind of annotate when requests failed, whether that failure was internal or external, whether it's part of the app or part of the service mesh. We've got very extensive metrics that split things out by connection level versus application level versus mesh level. We dump as much internal state as possible because you don't need it normally, but when it's time to diagnose things, it's really helpful to understand what Linkerd is thinking in its brain. Human-facing admin dashboards, we got error tracking commands. There's all sorts of fun stuff you can do. So this was a big lesson for us as service mesh creators. All right, failure scenario 3. Our thing is broken, right? So you've deployed it to production. Congratulations. Our thing is broken. It must be the service mesh, right? Once you've introduced the service mesh, it's this new, strange thing, and it sits in between all this communication. And it's just going to take a while. It's just going to take a period of time where people are blaming it for everything. So I talked to a bunch of our Linkerd production users, and I asked them for examples, and everyone had like 3 or 4 examples at hand of things that Linkerd had been blamed for that turned out not to be Linkerd's fault, right? So a couple examples here. Our app servers are failing. We've got this big prod outage. Must be Linkerd. Well, the app servers were running out of file descriptors. Linkerd's slowing everything down. I got this network latency. Turns out we had an MTU mismatch for network time. That's some network thing, I guess, that makes things slow. Services are dying. Okay, well, the services had bugs, but they weren't logging the bugs, and Linkerd was logging all the failures, so of course you blame Linkerd. Connection timeouts, turns out the hardware load balancers were running out of IPs and were reusing ports or doing something totally wacky. Apps were unreachable. We misconfigured our firewall. There's probably another 20 things I could put on here. You can't avoid this, right? You have to just get through this. You can be prepared for it, right? And the way to address this is understand what the service mesh does and what it doesn't do. Use a service mesh that has lots of diagnostics in it that you can introspect, that you can debug. And then most importantly, you have to do some kind of outbound education, right? Everyone who is affected by the service mesh, all the stakeholders in that, in the first part of this talk, they need to be educated. You need documentation. You should be doing lunch and learns. You should be teaching teams not only what the service mesh is doing, but how they can diagnose issues themselves. And if you can accomplish that, then organizationally you'll all move past this period and everyone will become happy service mesh enthusiasts like me. All right, so far so good? We're on the last one. All right, failure scenario 4. Things go wrong, and it is the service mesh. This does happen, all right? And this is Morgan's 3rd law. To take down prod, first you must be in prod, all right? So if you don't want this to happen, there's one way I guarantee you can avoid this permanently, which is never put anything into prod, all right? So this is going to happen, right? And this is not, again, this is not service mesh specific. Any tech that goes into prod is going to break, and you need to have a plan for it. All right, and we had a really great example of this yesterday with Oliver Beatty's keynote, Anatomy of a Production Kubernetes Outage. Linkerd took down a bank, sort of. And if you weren't there, my brief summary, which is probably not quite accurate, but Kubernetes had a bug, Linkerd had a bug, Monzo's mitigation for the Kubernetes bug exposed the Linkerd bug, and then there were human beings involved, so things got complicated. What I think is really, really good about this particular incident is the fact that there was a public postmortem, and it was clear that there were lessons that they were learning from failure. Right? So you've got to be prepared for this. You're going to have real production failures. So remove the culture of blame. Right? If everyone is worried when something goes wrong, or if everyone's worried that they're going to get fired, you're not going to have a healthy organization. Learn from the failures and outages, quantify trade-offs. The Google SRE book has a great section on this. Right there, you can assign a cost to each successive 9 of uptime. You can make the system really, really, really reliable if you want to, but the cost goes up. You may not want to do that. It may be okay, and it probably is okay for things to fail some percentage of the time. And then understand the failure modes, right? Just like you're doing with Kubernetes, you got to do the same thing with the service mesh, right? Kubernetes is going to fail. You got to understand how that's going to happen. You need to have a game plan for when that happens. Same thing with the service mesh. Okay. Like I said, very little of this is actually service mesh specific. All right, so I'm going to sum it up in 6 easy steps. Number 1, make sure you're solving real problems, right? Not, I need a service mesh. Right? You got to have a concrete problem in there. Find the stakeholders, make them happy, right? By communicating, by understanding what they're worried about, by mitigating those concerns. I didn't talk too much about that, but there's a lot to be done there. Roll things out incrementally, because you will find things in prod that you've never found in staging or in testing. Get results quickly and communicate them. Right? It shouldn't take 12 months to do this. And then finally, accept that things are going to go wrong and have a plan. That's all of my wisdom. 2 years of production service mesh experience distilled into one talk. We have a couple other real-life examples for Linkerd and Conduit. If you're interested in tomorrow during the Linkerd deep dive, we've got a whole bunch of customer lightning talks. Franzi's giving a demo of some of the debugging and diagnostic stuff that we've built into Conduit. The Linkerd intro SIG is going to have a kind of a hands-on workshop. And then we had a couple talks yesterday, which hopefully you caught, but Israel, shortly after this talk, I think immediately after this talk, Israel will be talking about Linkerd at Molten. So we've got some real content for you. All right, thank you very much. I think we have some time for questions, so please feel free to line up behind the microphones if you dare. In the meantime, check out conduit.io, linkerd.io, give them GitHub stars. We are funded entirely by stars at this point. And yeah.
Awesome talk. So I just had a question around separations of concern. So, you know, when you have a platform team, as you said, that brings in, let's say, the service mesh, and you're already doing microservices, and then often people, like, you know, they debate, the platform team debates whether they should expose the developers towards, like, the implementation of, let's say, Linkerd, like understanding DTAB and how does that work and all those implementation details. Or you can just tell them, hey, like, you were using DNS for service discovery between services. Now you're just using path-based routing or something. Should we just expose that, or should we actually educate them on how Linkerd works, how the DTAP syntax works, and things like that?
Yeah, so the question was around kind of the separation of concerns. I think my suggestion would be, first of all, it's very organizationally dependent, but my suggestion would be the more that everyone understands what's happening, the better. But the less that they actually have to do, the better. So the ideal situation is that developers don't even know that Linkerd is there, right? They understand. I mean, they know it's there, but it doesn't affect them. They're not like writing DTABs or anything like that. That's the ideal situation. But that they understand that it's there, and they understand the failure modes, and so they understand when things go wrong, how to tell whether it's their stuff or your stuff. But yeah, that's a really good question.
Cool. Thank you.
Hi there. In my mind, service meshes are kind of a paradigm change from layered load balancing into distributed load balancing or reverse proxying. And that's something a lot of people I talk to have trouble sometimes understanding. How do you get people on board there?
I see. So how do you get people to buy into the service mesh model when what they're used to, let me press some buttons here, when what they're used to is kind of hardware level load balancing and that sort of stuff. So the way that we've been most effective at doing that's a great question, thank you. The way that we've been most effective doing that is by talking about layers of abstraction, right? So when you're in a world that, you know, there's like the layer 3, layer 4 world, right, where what you are thinking about, the kind of nouns and verbs are, I've got IP addresses and I've got to get packets from here to there and so on. And then if you shift up a layer of abstraction, you're at the level of services, right? And now your nouns and verbs are not IP addresses and TCP packets, but are rather, you know, RPC calls or HTTP calls and different services. And there are lots of parallels there. Right, so there is load balancing at both sides. There's flow control, and you know, at both layers, but it's at a different layer of abstraction. And I think if you put it in that context, you know, and you draw the parallels, and you say, look, the ideas are the same. We're still going to have load balancing. We're still going to have failure handling. We're still going to have flow control, but it's at a different layer of abstraction. Then that helps to it helps people understand, because we're used to that as engineers. Right? We know that there's like 7 other layers of abstraction, and we're always adding new ones in there.
So it's a broader question on service mesh and potential security concerns which keep coming up. So essentially, service mesh introduces a sidecar model, right? Whereas if you use the client library, it's part of the same container. So one question that often comes up is, are there any additional security concerns due to introducing a sidecar versus if I had just had the client library, it's all part of the same container?
Yeah, that's a good question. I don't know if I have a great answer for that. So the question was, are there security concerns about having something run as a sidecar versus having it be part of the same kind of compiled, you know, the same container? I think there are implications to that. I don't think that aspect is inherently more or less secure. Probably a container security person will yell at me for for saying that. My assertion is that by decoupling that code out of the application and by doing a bunch of the security stuff in the mesh itself, you actually end up improving things overall because you have one place where you're enforcing things like policy, one place where you're doing TLS, one place where you're consuming certs and all that stuff. So I think overall the picture is rosier, but specifically like what happens when you put stuff, you know, across a container boundary, I don't know. I'm sure it's fine. You know.
Thank you.
Probably fine.
Hi, thanks for your talk. I have a question. If I'm in the situation where I've identified that my use case is probably a good fit for a service mesh, you know, multiple different programming languages, different environments, but I have a hard dependency in the form of a legacy CGI-driven application that's been in production for 20 years, a lot of microservices in the cloud, but there's like this on-prem product. What kind of advice would you have for that kind of use case and getting that working with the service mesh?
Yeah, so that's a really common use case. It's very rare. Occasionally it happens, but it's very rare to introduce any of this stuff in a vacuum or in a total greenfield environment. Most of the time you have existing legacy stuff, and whether that's introducing the service mesh or introducing, you know, orchestration or introducing containers, you always have to bridge that gap. Do I have any specific advice about that? I think a lot of it comes down to how are you getting traffic in and out of the service meshed Kubernetes cluster. So a lot of it comes down to kind of ingress and egress. One of the things we see a lot of use, I'll just leave that off. One of the things we see a lot of use, one of the features we see a lot of use of for Linkerd for this environment, for this situation is Linkerd is able to talk to multiple service discovery backends and kind of bridge them together into a unified thing. So you can configure Linkerd to, you know, when you ask it for service foo, you say proxy this request to service foo, look that up in Kubernetes first, and if it's not there, then look it up in Zookeeper, and if it's not there, then refer to this file on disk, or look it up in DNS. And then you can, once you're in that world, you've kind of decoupled where services are from how to communicate with them. And then when you're moving things in and out of legacy and non-legacy environments, life gets a little bit easier. I think that's probably the most direct way of addressing that stuff. But that's a pretty general problem that everyone has.
All right, thank you.
Yeah, great question. Thank you. All right, anything else? All right, well, thank you very much for attending. I'll be hanging out. There's a Buoyant booth over there, so feel free to stop by and tell me about all the things I got wrong. And thank you for being a great audience.